Hello everyone. Today, I'm going to talk to you about effects of water management practices on rice yield and accumulation of arsenic and cadmium in rice. Plant absorbing essential and non-essential elements from the soil depends on many factors including concentration, chemical and physical properties of soil. 26. Root plays a crucial role in the uptake of element ions. Arsenic, As, and cadmium, Cd, are two toxic elements that have a relatively high risk of transfer from paddy soil to rice grain. Rice is a major dietary source of these two elements for populations consuming rice as a staple food. Reducing their accumulation in rice grain is important for food safety and human health. In the past, rice farmers in Vietnam always flooded their fields. This method was effective, but it also released arsenic from the soil. Arsenic is a toxic chemical that can cause cancer and other health problems. AWD is a new way to water rice that is more effective and less harmful to the environment. AWD involves alternating between periods of flooding and drying the soil. This helps to reduce the release of arsenic from the soil and also helps to save water. A study by Norton et al., 2019, found that AWD can reduce arsenic levels in rice by up to 27%. This is a significant reduction, and it could have a major impact on the health of rice farmers and consumers. AWD is a promising new method for reducing arsenic levels in rice. It is an effective way to save water, and it can help to protect human health. OM18 rice is an aromatic variety that was developed from the OM8017/OM5166 hybrid combination. It has several outstanding advantages, including high salt tolerance at 3 to 4 levels, pest resistance, particularly against blast, high yield, and a short growth at a net house in Q Long Delta Rice Research Institute in Kendo City, Vietnam in the spring of 2021. There were 3 treatments, CF, AWD, and D. Each treatment was implemented in a complete randomized block design measuring 2 by 5 meters and replicated 3 times. Here is a diagram of the experiments that were conducted. With a total of 9 experimental boxes for 3 treatments, in the CF treatment, the water depth was kept at 3 to 5 centimeters from when the rice was 8 days old until the tillering stage. Then, the water level was increased to 5 to 10 centimeters until the ripening stage. Finally, the water was drained, and the soil was kept dry until harvest, in the AWD treatment. The soil was kept at a water depth of 3 to 5 centimeters and irrigation was stopped 5 days after the first application of chemical fertilizer. Then, irrigation water was applied approximately 5 centimeters above the soil surface when the perched water table was at a depth of -15 centimeters. This process was repeated until the late ripening stage. A plastic pipe with multiple small holes was inserted into the soil to measure the depth of the perched water table. For the dry cultivation treatment, the field was kept saturated with water to a depth of approximately 1 centimeter during the first 2 weeks after sowing. Afterward, water was only applied as necessary for the growth of the plants, at the maturity stage. The grain yield was assessed by drying the grains under the sun for 3 days at a temperature range of 29 to 35 degrees Celsius and then measuring the yield. The yield components, including panicle number per plant, spikelet number per panicle, grain filling percentage, and 1,000 grain weight, were determined from 12 plants as one biological replicate. The experiment was conducted with 3 biological replicates of carbohydrates, so the use of a mixture of nitric acid and hydrogen peroxide, which are strong oxidizing agents, is the most suitable method to destroy the matrix sample. The procedure is as follows. The rice sample after being finely ground will be decomposed in 10 milliliters of nitric acid at 100 degrees Celsius for 12 hours, then 2 milliliters of hydrogen peroxide is added and decomposed in a microwave oven. The sample is then standardized and filtered through a 0.45 micrometer filter. Step 1 Sample preparation. Grind the rice sample finely using a cryomill. Weigh 0.50 g of the rice sample accurately to 1 milligram into a COD tube. Step 2 Extraction. Add 50 L of 200 U alpha amylase solution and 1 milliliter of deionized water to the tube. Shake at 100 rpm in a water bath at 95 degrees Celsius for 30 minutes. Add 4 milliliters of extraction solvent with a ratio of H2O, ETOH 99.9%, HNO3 65% equals 95 to 2.5 to 2.5. Vortex, shake in a water bath for 60 minutes, vortex after each 30 minutes. Step 3 Sample cleanup, centrifuge the extraction solution at 4000 rpm for 10 minutes. Collect the supernatant, wash the residue with 2 milliliters of deionized water. Vortex, centrifuge, combine the supernatants, adjust the volume to 10 milliliters. Filter through 0.45 millimeters and 0.22 millimeters nylon membranes. The extract was diluted 1:1 with a 50 millimeters ammonium carbonate solution, followed by a 45 millimeters ammonium tartrate solution. The carbonate tartrate mobile phase has the ability to reduce precipitation in multimetal samples such as Fe, Ca, Mg, etc. With an optimized gradient program, it is possible to separate 4 forms of arsenic that IAS levels above 100 Ing/G were detected in rice produced through CF practice, which is higher than the recommended limit for rice used in producing food for infants and young children, as stated in the Commission Regulation EU 2023/465. The grains in all 3 treatments were found to have a concentration of CD that is within the permissible limit of 200 Ing/G set by the Commission Regulation EC No 1881/2006. Although the AWD method has lower productivity than CF, it can still reduce IAS to a safe level. Based on data from Q Long Delta Rice Research Institute, the OM18 variety have a range of yield from 5 to 8 tons/ha, therefore, the productivity of 5.81 tons/ha achieved with the AWD treatment falls within this acceptable range. Despite having the lowest productivity, the D treatment removes the majority of IAS in rice. The level of IAS in rice using the D formula is suitable for the strictest requirements, 0.02 mg per kilogram, for products such as infant formula, follow-on formula, foods for special medical purposes intended for infants and young children, and young child formula, according to the Commission Regulation EU 2023/465. Compared to the CF treatment, the AWD treatment had little effect on the levels of vitamins B1, B5, and total nitrogen in rice. However, the D treatment, due to the lack of water, changed the growth process and led to a significant decrease in the vitamin B content in rice. The AWD treatment had little effect on the levels of vitamins B1, B5, and total nitrogen in rice. However, the D treatment, due to the lack of water, changed the growth process and led to a significant decrease in the vitamin B content in rice. EN 14122:2014 Foodstuffs Determination of Vitamin B1 by High-Performance Liquid Chromatography, ISO 20639:2015 Infant Formula and Adult Nutritionals. Determination of pantothenic acid Vit B5 by ultra-high-performance liquid chromatography and tandem mass spectrometry method, UHPLC-MS/MS, ISO 20483:2013 Cereals and pulses, determination of the nitrogen content and calculation of the crude protein content, Geldel method. The study found that AWD and D techniques can reduce the levels of arsenic in rice. This is important because the EU has standards for low arsenic levels in food for young children. AWD methods have the potential to increase cadmium levels, but they were the most promising management strategies in the study for reducing both arsenic and cadmium levels while keeping rice yield within an acceptable range. In conclusion, AWD treatment had beneficial effects on some traits related to water consumption and inorganic arsenic levels, but it negatively impacted other traits such as yield and cadmium concentration. The results of the study provide valuable insights into the selection of appropriate water management practices to improve rice yield and quality while minimizing the accumulation of harmful substances in rice. I hope this is helpful. Let me know if you have any other question. Thank you for your time.